Hello my lovelies, it's Susanna, and today I want to show you how to solve this problem. Given an isosceles triangle ABC with alpha is equal to beta is equal to 65 degrees and an area of A is equal to 11.5 square centimeters. What is the length of the base AB? Okay, this is about an isosceles triangle, so maybe let's draw this triangle first so that we know what we're working here with. An isosceles triangle is a triangle where two sides have the same length and then we have a third side here. They say that our base is AB, so this is our base then, so that we have A here, B here, and C here then. Alpha and beta are also given 65 degrees. So here we have alpha and here we have beta. And they give us the area of our triangle. So the area A is 11.5. And we have to find the length of the base AB, so this length here. Let's call this side X. This is what we want to find. And then we have the other two sides of equal length. I just call this side Y then. And because this has the same length, we have Y here as well. Okay, how can we find X now? Well, the area is given, so let's use this. How would I find the area of this triangle? The formula is base times height over 2. This is the area of any triangle, and they already give us that this is 11.5. What is my base and what is my height here? The base is our x, so instead of b, I'm going to write down the x, and the height is the side that is here perpendicular to our base, so this is our height of our triangle to this base here. Okay, so we have an equation. The problem just is that there is x and h in there as unknowns. So maybe we can find something out about h so that we can replace it here. Let's try and find something about our h. Well, this triangle is now divided into two smaller triangles. Can you see here on the left side, this is a triangle as well. And because we have a right angle here, this is a right triangle. And if I just draw this left triangle down here, we have the right angle here. The 65-degree angle is still here. This is my side H, this is my side Y, and what about the length of this side down here? Because this is an isosceles triangle, this part here is just half of the entire side. So the entire side was x, and if I take half of x, this would be x over 2. Okay, so we have this right triangle. We want to find something about our h. We have an angle. We can use sine, cosine, or tangent to find something out about our h. The question is just, are we going to use sine, cosine, or tangent? And so TOA can help us there to decide if we want to use sine, cosine, or tangent. We are looking for h, and h lies across our angle that is given. Where is the hypotenuse in this triangle? Always across the right angle, so the hypotenuse is y. we don't know anything about y, so I don't want to use the hypotenuse at all. So hypotenuse would be in here. I don't want to use the sine. Hypotenuse would be in here. I don't want to use the cosine. So tangent is our friend here. So the tangent of our angle 65 degrees is equal to the opposite side over the adjacent side. The opposite side of our angle is here across our h, so the opposite side would be h, and the adjacent side would be not the hypotenuse, but the other side that is here at our angle, which is x over 2. So the adjacent side is x over 2. Okay, now we have an equation. We can solve this equation for h because we wanted to find something out about h, right? So maybe let's multiply here by this denominator by x over 2 on both sides of the equation so that we only have h left because this cancels out here. So this is my h. And here, well, I have this beautiful expression here. I don't want to calculate the tangent of 65 degrees yet. I want to take it with me till the very end because this is an exact value then. So I'm going to work with this as my h from now on. So this is what I wrote down here again. And if we go back to the beginning here, to our area that we already had, this equation where we have x in here, but also h, we can now replace h by the thing we just found. But maybe before we insert, maybe let's get rid of this fraction here by multiplying by the denominator by 2 here and by 2 here so that we make this a little nicer. So this cancels out and we have x times h. And on the other side, 11.5 times 2 is 23. And now I want to insert h here. So we have x times, instead of my h, I just take this entire thing here. This was my h. And on the other side, I have 23. And now this is an equation. There is only x in here, and we can solve this equation for x. Let's try this on this page here. We still have this fraction here, so let's multiply by the denominator again, so by 2, so that we don't have this fraction at all anymore, because this cancels out here, and we have x times x, which would be x squared, and then we still multiply by this beautiful tangent, and 23 times 2 is 46. To solve for x, we have to get rid of the tangent now. So let's divide both sides by this tangent of 65 degrees here, and the same thing on the other side, so that this cancels out now and only x squared is left. And here I still don't want to calculate it, so let's write it down as it is and let's work with this expression now. We still want to solve for x, so we only have to get rid of this square here. We can do that by taking the square root on both sides of the equation. If we do that, we get two solutions for our x here, a first positive solution x1 and a second negative solution x2. The positive one is just the square root of everything that we had inside here. And the negative solution is minus everything that we had here. So we will get this square root here again with everything that was inside. What do we say to this negative solution for our x? X is the length of a side, which cannot be negative. So we are not interested in this solution here. We only found this exact solution, and if we want to take it now and type it in our calculator, we can do that and get a result of 4.63 for our x. So let's go back to the beginning here of our triangle. This was the length we wanted to find, and we just solved this problem. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!